4.3, determine the equation of a line. So we're going to recall the y-intercept is a point where the graph crosses the y-axis. Okay, and at this point, we can say like the y value when x equals 0. Because if we took a look at the x value, there's no left-right movement, so there's only that y value. So x equals 0. Okay, the equation of a line can be determined from a graph by finding two things. We want to find the slope, and we want to find the y-intercept. Okay, so y equals mx plus b. We want to fill in the m and the b. Okay, to graph the line, there are two steps. One, plot the y-intercept. Okay, that's going to be our reference point. And then two, use the slope to get your next point. I usually do 2 points. Let's see, next 2 points, just so that if they're spaced out a little bit more, I'm drawing the line very accurately through them so that I can read the graph. The more points you do, the more accurate your line is going to be. Okay. The equation of a line can be determined from a table. So like we're talking about like table of values by identifying the slope, right? We're looking at the differences in the y column. And then what we can do is we can pattern it back to the y-intercept. So again, when x equals 0. Okay, but we'll do questions like that. And the equation of a line can be found if given the slope and any point. Okay, so we would be given the m, the x, and the y, and what we would be doing is solving for b. Okay, so let's start these questions. We're going to do one at a time, so hopefully it's not too much. I know that this was a lot, but let's chunk it up. Okay, example 1. Write the equation of each line in the form y equals mx plus b. So first, easiest thing to do is identify the y-intercept. So that's 2. Okay, so there's half of our equation. Now the slope. We're going to go from this point here to this point here, which is up 1, 1, 2, 3, 4, and then over 4. So this is a rise over run as a recall, which is 1 over 4. So the equation of our line here is y equals 1/4 x plus 2. Okay, we're going to do b the same way. So our y-intercept here is 5, and our slope, let's draw a triangle between these 2 points that the graph is plotted for us already. And we're going to go down 1, 2, 3, 4. So down 4 is -4, and we're going to go over 2. So -4 over 2, -2. So y equals -2x plus 5. Example 2, given each slope and y-intercept, write the equation of the line and then graph the line. So A, the slope is 2, the y-intercept is -3, so our equation is y equals 2, I should put b there instead of y. Okay, y equals 2x minus 3. So let's first plot the y-intercept. We need that reference point. Where do we start? Okay, this is step 1. Now we're going to apply the slope. So the slope is 2, which is actually 2 over 1. So our rise is going to be 2, and our run is going to be 1. So up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1. And you can keep patterning up until we have enough points to draw our line. Okay, and then you want to draw arrows on the ends of your line and then label. Okay, so the slope is -1 over 1, right? And then the y-intercept is 6. So let's plot this first. That's our reference point. That's where we start. And we get, this is going to be rise over run. So our slope is -1 over 1. So we fall 1 over 1, fall 1 over 1, fall 1 over 1, fall 1 over 1. Okay, and then you just want to graph a bunch of these points. and then label y equals negative 1x plus 6 is our equation, right? Slope, y-intercept, and we just label our line. Okay, and C, the slope is 0, okay? So slope is 0, which means it's a horizontal line, and the y-intercept is negative 5. So we can write this as y equals 0x minus 5, but this would actually cancel, and we would get y equals negative 5. So let's plot a point at negative 5, and then it's just going to actually be horizontal. Y equals negative 5. Okay, example 3. For each linear relation, find the value of y when x equals 0. Okay, then determine the equation of the line. So if we actually take a look here, we want this point. So let's actually just box this. Okay, we want this point when x equals 0. This is our y-intercept. So whenever you're looking at a table of values, you can always identify the y-intercept. It's when x equals 0. I mean, if it's included in the table of values. If not, we can always pattern. So x's are going up by 1, so that's fine. We can pattern. 14 to 12, we're actually like going down by 2. 12 would go to 10, right? Because we're subtracting 2. 10 would go to 8, and then 8 would go to 6. Now B. Oh, actually, let's finish A. We'll pattern B in a second. So our y-intercept is 6, and our slope, so the slope is actually what it goes up by, so it's actually going up by 2. Okay, so our equation here is y equals 2x plus 6. Now, in B, we have the first point 2.5, and then we go up to 0. Or we go down to 0. So what we're doing for the pattern only is we're subtracting negative 2.5 every time. So 0 minus 2.5 is negative 2.5. Negative 2.5 minus 2.5 is negative 5. Subtract another 2.5, negative 7.5. And this right here is our y-intercept. Now our slope is actually going this way as well. The slope is, we're going down by 2.5. So our equation is y equals negative 2.5x minus 7.5. Now, if we're looking algebraically, what we're going to run into is we're going to be subbing in an x, a y, I'll make this darker, x, a y, and m, and we're going to solve for b, right? Question mark. So it's going to look something like this in the next couple questions. So this is just simplifying and rearranging. So I'm going to bring down the 5. 3 times 2 is 6. Bring down the plus b. Now isolate for b. Negative 6 on both sides. Those cancel. What is 5 minus 6? It is negative 1. Okay, bring down the negative 8, bring down the equal sign. What is 2.5 times negative 3? I get negative 7.5. Bring down the plus b. Now, opposite operation to negative 7.5 is plus 7.5. So I get negative 0.5 equals b, right? Because this was negative 8 plus 7.5. If you wanted to rewrite it. Now, bring down the 10. 1/2 of 6 is 3. Bring down the plus b. Let's get rid of the positive 3. We're going to go negative 3. Okay, 7 equals b. Now, what we're going to do is that same idea of simplifying and solving for b, but what we're going to do this time is we're going to be responsible for actually subbing in values to y equals mx plus b. So example 4, a line with a slope of 2, well slope is m, so we can go ahead and sub in the 2 for m, passes through the point 4, 3. which is x comma y. So x is going to be 4, and our y is going to be 3. Okay, determine the equation of a line. Well, we already have m, because our equation of a line, we always want to put it into 2x plus, and then we want to always insert the m and the b. Those are our two values. So 3 equals 8 plus b. Then this 8, we're going to subtract 8. So we have 3 minus 8 equals b, negative 5 equals b. Okay, so the equation of our line is y equals 2x plus, and we can put negative 5. If you don't want it looking like that and you would like for it to be, just have one sign here, you can always put y equals 2x minus 5. That's probably more common. Okay, we're going to do the same thing in example 5. Determine the equation of a line, and we're given the slope and a point. So this is x, this is y. Y equals mx plus b. Let's go through them in order. What is our y value? Negative 3. What is our m value? 2. What is our x value? 5. And then we're solving for b. So we get negative 3 equals 10 plus b, and we're going to subtract 10. So negative 13 equals b. Our equation for this line is y equals 2x minus 13. Okay, because the 2 is already given. Exact same thing for b. Y equals mx plus b. We have m, and then we have x and y. Let's go in order. What is our y value? 7.5. What is our m value? Negative 0.5. What is our x value? 0. And then we're solving for b. Well, bring down the 7.5. Negative 0.5 times 0 cancels, and we get 7.5 equals b. So our equation for this line, we need our slope, we need our y-intercept, negative 0.5x plus 7.5.